Yes, hello. We are now going to do homework 3 and exercise 2. And we start here. Some information are given in the text. We know that the sum of three numbers here can be written like this. The sum over I from 1 to 3 is the same as A1 plus A2 plus A3. And then we will take this a little further. And let these three numbers be sums. So let A1 now be the sum from j equal 1 to 3 to 2 in the power of 1 plus j, and A2 and A3 as you see. So A1 is a sum, and A2 is a sum, and A3 is a sum. And then we know that the sum of these three numbers can be written as A1 plus A2 plus A3, which is actually the sum of 2 in the power of 1 plus j from 1 to 3, plus the sum of 2 in the power of 2 plus j for j from 1 to 3, and plus the sum of 2 in the power of 3 plus j, j going from 1 to 3. So then we can start with A, where we are asked to calculate following. The sum I equal 1 to 3 over the sum j equal 1 to 3, 2 in the power of I plus j. So how can we do this? This is equal to, first I let I go from 1 to 3. So if I is 1, we get the sum from j equal 1 to 3, 2 in 1 plus j. And then I let I be 2. So then we get the sum j equal 1 to 3, 2 in, and remember I is 2, so then it's 2 plus j. And then I gets its last number, 3. And then we have to plus the sum j equal 1 to 3 to the power 2 in the 3 plus j. So then we have used the first summation sign. And now we can actually write out all these three sums, which we take the first one first. So then that is 2 in 1 plus 1, j equal 1, and then let j equal 2, we get 2 in 1 plus 2, plus j equal 3, 2 in 1 plus 3. So that was this one. And then we take this one, plus, now j is 1, then we have 2 in 2 plus 1, plus 2 in 2 plus 2, plus 2 in 2 plus 3. j from 1 to 3. So that was this one, and then we take the last sum and write that out. So that is 2 in 3, and first j is 1 plus 1, plus 2 in 3 plus now j is 2, and plus 2 in 3, because here it stands 3, and j is now 3 plus 3. So then we get 2 in power of 2 plus 2 in the power of 3 plus 2 in the power of 4 plus 2 in the power of 3 plus 2 in the power of 4 plus 2 in the power of 5 plus 2 in the power of 4 plus 2 in the power of 5 plus 2 in the power of 6. And we can now rearrange here, so let's write this as 2 in the power of 2 plus 2 in the power of 3 plus 2 in the power of 3. So I now use this one, I've used this one, and I've used this one. And then I take the powers of 4, so then I get 2 in the power of 4 plus 2 in the power of 4 plus 2 in the power of 4. So that was this one, and this one. And then plus 2 in the power of 5 plus 2 in the power of 5 plus 2 in the power of 6. And we could calculate this as in many ways, but now I'm doing this way. 2 in the power of 2 is 4 plus 8 plus 16 plus 16 plus 16 plus 32, and 2 in the power of 5 is 32, and 2 in the power of 6 is 64. So then we have, here is just 1/4, like this. And 2/8, like this. So, and then we can compute this, and we will find that this gives 196. And then we can take B. Here we are asked to show that the sum k equal 1 to 4 over the sum j equal k to 4 bj is equal the sum j equal 1 to 4 j bj. So this is what we are going to show, and when we are going to show things, we have to start with what we are going to show, or the starting expression, and the starting expression is here, the sum k equal 1 to 4, sum j equal k to 4, bj. And first I let k be equal 1, so then now I use the sum to the left first, and then k is first 1, and then I get the sum j, if k is 1, then j equal 1 to 4 bj, plus, and then I let k be 2, then this will be j equal 2. So the second sum is now j equal 2 to 4th, and when k is 3, we get j equal 3 to 4, and in the end, when k is 4, we get j equal 4 to 4 bj. And we can rewrite this like b1 plus b2 plus b3 plus b4. That was this sum written out. And then I write this sum out, which is plus b2 plus b3 plus b4. And then I get plus b3, because now I start at 3, j is 3, so then it's b3 up to 4 plus b4. And this last sum is just b4. And I can rearrange these terms now and write it like this: b1 plus b2 plus b2 plus B3 plus B3 plus B3. So here was the B1, here is the B2, here is the B3, and now I take the B4, which I got 4 of them. So plus B4 plus B4 plus B4 plus B4. And if we actually study this carefully, stirring on it, we will see that this is actually the same as, okay, I can write one more line just to make it totally obvious. So here we have 1B1 plus 2B2 plus 3B3 plus 4B4 equal, and then by stirring at this, we will see that if this is a sum, j equal 1 to 4, j bg. Because if you write this out now, you will get 1b1 plus, and then j is 2, 2b2, and j is 3 plus 3b3, and j4 plus 4b4. So that was just a confirmation. So here we have showed it. So that was exercise 3. Then we can do exercise 2, I mean. And then we can do exercise 3. And in exercise 3, actually we are just going to convince ourselves about a couple of things. But that can be important enough. So we will absolutely do that. So you have an intro to this exercise. I ask you to read that by yourself. But okay, we can write this then, given f of x equal probability of x equal x, a probability mass function. The expectation of x is expectation of x equal the sum I equal 1 to sum x element in x to x times f of x, comma, where this big X is a discrete random variable taking its values in this X. In the space X. So, and you have an example, but the point here is that we need this expectation, this formula for the expectation, and that it's what we are going to use later on. So now we see at, especially in exercise 4. So this is both for exercise 3 and for exercise 4. So let x1 up to x50 be 3 different numbers. One, 2, and 3. And suppose that xi is equal 1 for I equal 1 to 5, xi is equal 2 for I equal 6 to 15, and xi is equal 3 for I equals 16 to 50. So first of all, we are going to convince ourselves that the sum over I equal 1 to 50 xi is equal 5 times 1 plus 10 times 2 plus 35 times 3. So why is this true? Okay, let's write this sum out. I equal 1 to 50. Xi, that is actually equal x1 plus x2 plus x3 plus x4 plus x5 plus x6 plus x7 plus x15 plus x16 plus x50. And you know that these first 5 terms is actually equal 1. That we have information of that in the text. So actually it stands here 1 plus 1 plus 1 plus 1 plus 1. And then we have plus 2 plus 2 plus 2 a lot of times. And then we have plus 3 plus 3 most of the times for I equals 16 to 50. And then we see that we have 5 ones, so we just take how many times do we have the number 1? We have it 5 times. So therefore we can write this as 5 times 1 plus, and then we see that we have 2 10 times for x6, x7, x8, 9 up to 15. So we have then 10 times 2 plus, and from x16 to x50 it's actually 35 values. So we then got 3 times 35 times 3. And this is equal 130. So then I hope you are convinced. And we do B, which is the same task actually, in some sense. But first we get to know that let x1, x2, xn be random variables taking their values in the sample space x 1, 2, 3, or in the space 1, 2, 3. For x element in this space 1, 2, 3, we write which shall be understood as the number such that xi is equal x. So we are then asked to convince ourselves that the sum I equal 1 to n xi is equal 1 times the number such that xi is equal 1 plus 2 times the number such that xi is equal 2 plus 3 times the number such that xi is equal to. So we can convince ourselves by thinking about the last exercise A, 3A. So then if we look at exercise 3A, this will be equal 5, and this will be equal 10, and the number of such that xi is equal 3 is equal 35. 35 times we have then xi equal 3. So then we could rewrite the sum as, and we could then rewrite the sum as the sum I equal 1 to n xi equal 1 times 5 plus 2 times 10 plus 3 times 35, which is equal 130. So that's an explanation of this word notation. And at last we are going to convince ourselves that xn bar is equal 1 divided on n, sum xi, I equal 1 to n, is equal one times the number such that xi is equal 1 divided on n plus 2 times the number xi is equal 2 divided on n and plus 3 times the number such that xi is equal 3. So then we have that this is written, we can write this as 1 times the number I xi equal 1 plus 2 times the number xi equal 2 plus 3 times the number xi equal 3 divided on n. So here it should be pretty clear that we take the sum of all the x's and divide on n, and that is how we calculate the mean. So using the numbers from exercise 1a, we get that the mean x bar 50, because it was 50 numbers, is equal 1 divided on 50, sum I equal 1 xi to n, is equal, and I fill in the last formula here, 1 times 5, because we have 5 ones, plus 2, we add 2 10 times, and then we add 3 35 times before we divide on the total observations, 50, and then we get something which is actually 2.6, because this is 130 divided on 50. So then I hope you are convinced about notation here. So it's nothing else but notation, and then it's exercise 4. So consider a random variable x taking its values in -1 to 1 with distribution. Okay, let's write it. Consider the random variable x taking its values in -1, 1 with probability mass distribution such that probability of x equal 1 is equal 1/2. And then we are asked in A to find what is the probability of x equal -1. So the probability of, since we have just 2 possible outcomes in this space, minus 1 and 1. The rest, the probability of x equal minus 1 has to be 1, the probability of being in the space, minus the probability of x equal 1, which is 1 minus 1/2, which is equal 1/2. And that was A, and then we can take B, and we are going to show that the expectation of x is equals, okay, we are going to show that the expectation of x is equal 0, but we know that the expectation of x is the sum over all the x's in the sample space x times the probability of x being equal x. And here we have minus 1 as 1, so this is, if you should be in doubt, this is space x. So minus 1 is one possibility, and the probability of this one is, so it will be minus 1 times the probability of x equal minus 1 plus the other possible outcome, 1 times the probability of x being 1. So then we get minus 1 times 0.5 plus 1 times 0.5, and this is minus 0.5 plus 0.5, which is equal to 0. So that's it. So then we take the two next exercises in a new video.